Hello, and welcome to the CBT Nuggets IC&D2 video series. My name is Jeremy Chara, and I'm extremely excited to get going into this IC&D Part 2. I don't mean to set your expectations high or anything like that, but this series is going to be awesome. Look at me. I can't even talk. That's how awesome it's going to be. I just got finished recording the CCENT, or ICND1, which is really good. I'm really happy with it. It is kind of an intro to networking, an introduction to Cisco. It talks about some of the key configurations of LAN switches and of routers, and it was a really good package. But the reason I'm so excited to get into this is because this is where the technology really hits the road and starts running. I guess the best way I can describe this is, have you ever seen the movie Aladdin? It's an old Disney movie, a cartoon for kids. And there's a part in that movie where this evil sorcerer, it's near the end, this evil sorcerer kind of moves up to the next level of his power. He becomes a genie, and you just see him explode out of this building, and he goes, ah ha ha, the world is mine to control. He's got this evil villain kind of voice. And not that I'm an evil sorcerer or anything, but that's kind of what I feel like. When I was going through ICND1 or CCENT, I would go through the configurations and I'd start going. It's like you start on a, kind of a smooth jog, and you're going and going, and all of a sudden I'd get to a point and I'd stop. My mind would say, wait, you want to take them there? But I couldn't, because it was way beyond the scope of the ICND1 exam. But now we can go there. It's almost like we can start with this jog, and that's what these initial videos are going to be about. I'll explain those in just a moment. And we can just go into this full sprint into this technology that will just blow your mind. It's awesome. So let me talk about what we're going to do as we begin this series. I'm starting off by rebuilding the small office network. It may have been some time between the CCENT series and this series for you, so I intend these first few videos to be sort of a refresher in a very practical cram session sort of way. Just about everything that we do in these videos, first few videos, are going to be all live demonstration, meaning you're going to see a network topology, and we're going to build it. We're going to be walking through configuration after configuration, and I'm going to go through and review the key LAN concepts as we're configuring them, and the key LAN configurations, just to get your blood flowing again. Even if it hasn't been a while since the CCENT series, even if you just got certified, I would still say this is still good for you to go through, because it's going to relay that foundation that as we get into the series, I'm going to assume we're all on the same page and get us all ready to go. So what we're going to start off with is LAN concepts, meaning the switch. That's usually where most networks begin, is all the PCs and servers connecting to a local area network switch. We're going to get that switch configured and then move into the routers and begin configuring our internet connections and wide area connections between offices. This is where we'll begin. This is our network that we're going to rebuild as we begin this series and then begin enhancing as we go through. We have 3 routers that we're going to be configuring in the upcoming videos. One that's connected to the internet, 2 of them that are between offices. Essentially, this over here represents one office, and then we have a WAN link over here to another small office over here. So we'll configure those routers, but what we're going to focus on right now is, got the orange halo right around it, the switch. We're going to work through the LAN configurations, beginning with wiping out old configs. We're going to clear the switch out, get it back to its base configuration, and then begin by configuring the security, the cosmetics of the switch, meaning the name of the switch, the work environment that we're going to be working in. We'll get management set up for the switch, where we can telnet to it remotely and manage it. We'll work on configuring the interfaces, hard-coding speed and duplex, and assigning descriptions where we see appropriate. And then finally, we'll verify our configuration using many of the show commands and show CDP to make sure what we're connected to, that's Cisco Discovery Protocol. And then we'll back up our configurations to a TFTP server. So let me go ahead and slide our window in here. This is our switch that we actually used in the CCENT series, and I want to begin by eliminating everything that we did. Logon banners, passwords, everything like that. It's all wiped out when you do one of 2 things. One, the old way, we can type in write erase, hit enter. It says erase NVRAM file system will remove all configurations. We hit enter and we are good. That will wipe out the NVRAM. Now, depending on the device that you're on, the newer way is either erase, and you can do a question mark, and you can just do startup config, or some different devices, namely routers and some switches, will be delete startup config. So erase or delete, either one works, and does the same thing as the write erase. It's just write erase is considered legacy. Now that kills the NVRAM. There's our concept to review. Non-volatile RAM. That's the RAM that will remain when the power goes out. But the configuration is still active on this switch in the RAM. So to truly flush it out, we need to do a reload of the switch. Now be careful. I've done this plenty of times just on instinct. It comes up and says, system configuration has been modified. Do you want to save? And you think, oh, yeah, because you always save, right? But if you save, you just undid everything that you just did, because it's going to write everything from RAM, meaning the stuff we're trying to erase, back to NVRAM, and it's going to boot up with its same old configuration. So I'm going to say, no, I do not want to save, and then it says, proceed with reload. Sure thing. So this will reload the switch. It's going to go through the boot process, and I'll pause the video as it does that. But once it comes back up, it will have no configuration and should give us that ever so lovely question, do you want to enter initial config dialog? So let me pause the video here. All right, we've made it through the boot process, and just to review what the boot process looks like, we right about there did the reload, and it went through, booted up. All of this pound symbols action is it copying the iOS out of flash into RAM so it can run faster, and decompressing it as it does that because it's compressed in flash. You can see right there, uncompressed and installed. Gives some copyright information, yada yada. Runs through and tests all the core components. Some cryptography warnings about exporting to countries that don't allow that. There's our model number of switch. This is our memory installed inside of the switch. That's our RAM. Shows the image that it's running. It's a layer 2/3 image. All the controllers that are inside of it that actually manage the interfaces. Down below, you can see system serial number and so on. But this is just some of the status messages. Now that it's up and running, we can hit enter and see, do you want to enter the initial config dialog? Now that you have graduated to the IC&D 2 level, we always answer no to that. We went through it in IC&D 1 just to see what it looked like, but just get a few questions into that and you realize that's not where you want to be. You want to be at the command line where we can manually configure things, because that's where we can do things much faster and more efficiently. So I'm sitting at the switch. Little right angle bracket lets me know I'm in user mode. Now let's look at our objective. We've wiped out the configurations. Let me grab my pen here. And we are good to go on that. Now we can do the passwords and banner to lock it down. Now there's a lot more to that than meets the eye. We have not just passwords for the privilege mode, but passwords for telnet and things like that. So let's walk through it. First off, to move into privilege mode, we type in enable. Tab key finishes the command. I'll move into global configuration mode and set the most important password of all first, the privilege mode password. We can do it one of two ways. We can type in enable password, and whatever we want our password to be right there, I could put Cisco as my password. But the problem with the enable password command is that it stores it in the running config in clear text. Most people, if not all, use nowadays the enable secret, which will hash the password in the running config. It's a pretty sophisticated form of encryption that makes it virtually unbreakable. So I'm going to choose the enable secret Cisco, which is the worst password you could ever use in the real world, but in lab environments it's great because you'll never forget it. So we've now protected our privilege mode. Just to test, I'll type in disable and enable one more time, and now it's prompting me for a password, which I type in Cisco. Now let's lock down the telnet ports. We do that by typing in line VTY 0-4, where 0 is the first VTY port number and 4 is the last. So it's kind of like typing line VTY 0 through 4. So I'm configuring all of them at the same time. Now remember, the VTY stands for virtual terminal and virtual See, here's your fact of the day. A lot of the documentation say it's virtual terminal, but it's actually not. It's virtual teletype. That was one of the, you know what? Hang on. Okay, sorry. I just had to go to my web browser and verify that. It is virtual teletype, which is an old system that we had of communicating, and now we use Telnet to connect to our virtual teletype ports. So I'm under line VTY 0 space 4. I'll type in login. What that does is require logins to those ports. If I were to negate that and type in no login, oh, that's so dangerous. Because at that point, people can telnet into the router and there's no login required. It's not saying no logins allowed, it's no login required, so they can log in without a password. So we type in login, you notice it says the login will be disabled until you set a password because you've told me to require logins, but haven't told me what password to use. So we'll type in password of Cisco. I hit enter. I've now secured my telnet ports with the password of Cisco. Let's jump out. Line console 0. We want to lock down the console port. We'll say login, and the password on the console port is also Cisco. And finally, line aux 0. Right, I'm on a switch. Switches don't have aux ports. Routers have the auxiliary ports where you can attach a modem, and that's one of the common things people do on routers, but switches don't have it. So we've got the VTY passwords configured, the enable secret password configured, and the console password configured. I would say we're good to go on passwords. Now let's set a logon banner. We do that by typing in banner MOTD, which is message of the day, and then we type in a delimiting character. Now that context-sensitive help isn't too helpful because it's kind of confusing. It says C banner text C, where C is a delimiting character. It just means type in whatever number or symbol you want. I'll use a right parentheses, enter. As soon as I do that, it started the logon banner, and I can, be nice and creative. Do not log on. Done. Put my asterisks as well. Now, I believe I mentioned this in the part 1 of the series, but if you haven't seen that one, I do want to mention that let me say this, it's not a good practice to make this logon banner excessively long. I've seen people that will put entire disclaimers and acceptable use policies and everything in here, even ASCII art, little pictures on there of men with guns that says, do not log in. While that's fun, it will slow your router down, meaning the running config will be larger, it's more to process, but more so, when you go to save your configuration, it just takes forever. So short and sweet, I'll end with my right parentheses, and now I have a logon banner. With that, I'll exit the router. It says console ports available. I hit enter. It says do not log in. My logon banner is successful. I also see my console password is successful because I'm prompted immediately for a password. I'm in user mode, privilege mode, password, good. So we've now got the passwords and the logon banner configured. Now let's move on to the cosmetics. We need to configure the name of the switch and our general work environment. Let's start off with the name of the switch. I'll jump into global config mode, real simple command, host name, and we can name it whatever we'd like. Let's call it well, this is what I named it before, but we'll call it that again. CB switch, we'll make it unique, 2. Creativity at its best. So CBT switch 2 is now the name of the switch. Now what I mean when I say work environment on the second half is just the things that makes the switch or router easier to work with. The first of those things is the synchronous logging, meaning if you're ever making changes and you're bopping around and so on, let's say we exit back to privilege mode and I say, I want to do show, I hate that. You get this message right here, right? It says configured from console by console. It's a status message, and you'll get tons of those. As interfaces go up and go down and all kinds of things happen on the switch, status messages will abound. But the problem is they cut what you're typing in half. You can see SH right there in OW, ow, over there. And I'm typing at the end of this message over here, which it will still work if I can keep my wits about me and keep typing it in, but it's difficult. So what I prefer to do is go under the console port and type in the command logging synchronous. Enter. I'll also go under the VTY lines because you can actually watch those messages from there, so I'll do the same thing over there. telnet ports will now have synchronous logging. Now watch what happens when I exit back out. I do a show running, oh, there it goes. We got the message, and it repainted what I was typing below it. It's such a simple feature. I don't know why it's not on by default, but it's so helpful not to have these messages interrupting you. Good. Now, one thing I'll show you for a lab environment that will be very handy is go under the console port and type in no exec timeout. Or you can type in exec timeout 0 space 0. It does the same thing. It keeps the router from kicking you off after 5 minutes of idle time by default. A lot of times we'll be working on our devices, we'll look at a book or look at a website or you know, we're configuring things and getting it set up, and we'll get kicked off and we have to log back in, get back to where we were. So this will keep it from kicking you out. Now I want to emphasize this is in a lab environment. In the real world, this is a huge security vulnerability because if you forget to log out, that means the next person that comes in after you is going to be logged in because it never kicks them out. Maybe just for your own wits, you could type in something like exec timeout, we'll say something like 800, where at 800 minutes of idle time it will log you out. But for me, I'd prefer just to keep it there all the time. Now, the last command for the work environment that I like to do on all my devices is type in no IP domain -lookup. It's from global configuration mode. What that command does is keep you from getting hung up on mistypes. Meaning, I didn't want to demonstrate it because it would hang there for about 60 seconds. But when you mistype something from privileged mode, it will typically sit there and go translating to 255, 255, 255, 255, and just hang there. There's no way to really break out of it, except on some of the newer devices. You can use the Control-Shift-6 to break it. But on a lot of the older and modern devices, you just are stuck there, and you have to wait there for 60 seconds. What it's trying to do when it's translating that is telnet to a device named ASDF, or whatever your mistype is, meaning the router thinks, or the switch thinks, that you're trying to telnet to something named that. If you don't have DNS set up on your switch or router, it's just going to send out broadcasts to the network saying, hello, is anyone out there named ASDF? Anyone? Bueller, come on. Let me know. And it'll just hang there and wait. And meanwhile, you're staring at a prompt just going, come on, come on. So no IP domain lookup immediately says, I'm not even going to bother looking up that name because it's probably just invalid anyway. So that is setting up the name of the switch and the work environment. Now let's get to the big one, management. Assigning a switch an IP address and a default gateway will allow you to manage it remotely, so you don't have to stand in those cold IT rooms and hook into the console port and shiver your way through the configuration. So let me expose a little bit more of this diagram. We have these IP addresses that I plan on assigning, at least initially. It gives us enough information to give this switch its IP address, 192.168.1.10, with a Class C subnet mask, and its default gateway, which will be this router that is connected to the Internet. Now, on modern Cisco switches, Cisco used to have many different ways to give a switch an IP address. Sometimes in the older ones, it was even from global configuration mode. But on modern Cisco switches, they prefer to give them to VLAN interfaces. Now, without getting too deep into the VLAN world, which will be a huge part of this series later on, by default, all switches have this interface known as VLAN 1, all Cisco switches. And VLAN 1 represents the VLAN that all the ports of your switch are assigned to. Now, again, we haven't really discussed VLANs too much up to this point. It's one of the new concepts we'll talk about in this series. But it's a way of managing... How do I summarize VLANs in a single statement? Let's just say it's a way of managing the ports on your switch and what networks they belong to. By default, they all belong to VLAN 1. So to give this switch a management IP address, we need to move into global configuration mode, get under the interface VLAN 1, and give it the IP address, 192.168.1.10, which is the IP we just saw in the diagram. Now it's going to ask us for the subnet mask. Someday, Cisco will allow us to use the CIDR notation or the slash notation, but for now we have to type it in decimal. So that is the IP address that's assigned, but be careful because the VLAN 1 interface is always administratively down by default. So what do we have to do to bring it up? No shutdown. There's been so many times, I can just relay one experience where I've configured devices and shipped them to clients, meaning that, it's for remote installations and stuff like that, and I kind of pre-configure the network, and I've done, configs in a hurry and just shipped it and forgot to do a no shutdown. And there's nothing more painful than, thankfully with this client, it was just a 2-hour drive, but there's nothing more painful than jumping on a plane, flying out, planning a 2-week trip to find out you just have to type in no shutdown. So we've now got the management interface brought up. And let me show you the first shortcut of the series. You know that show commands only work from privilege mode, right? I did this command right here with show IP interface brief to verify all the interfaces on my switch. Well, you can actually, on modern Cisco switches and routers, implement the new do command. I can type in do from any mode that I'm in, followed by a show command, show IP interface brief. And it will execute that show command from whatever mode I'm in. That's awesome. So I don't have to always exit back out. And I can verify that my VLAN 1 interface is up, line protocol is up, that means we're communicating, and this switch should now be able to be telnetted to since we've assigned it a VTY password and an enable secret password. One more piece of that puzzle, and that is the default gateway. That is a global configuration mode command. I'll type in IP default-gateway, and the default gateway I plan on using. That'll be my router up here. 192.168.1.1. Enter. We now, with that in place, can manage the switch from the local LAN, just by giving it an IP address, and remotely by giving it a default gateway. Without a default gateway, the switch has no way of getting off its local network. So at that point, the management of our switch is good to go. And the default gateway is set. So we can move down to the interfaces themselves, the speed, duplex, and descriptions. Now with the interfaces, all of them are set. Let me do a show run. By default, it'll probably hide it. All of them are set to auto-negotiate the speed and duplex of the interface. Now my quick witty saying on that is the auto-negotiation. Well, see, I ruined my own saying. With auto-negotiation, you not use it. Auto is typically bad in most things Cisco, meaning that, yes, it will work most of the time, but it leaves some room for doubt. And then with the speed and duplex, if it auto-detects it incorrectly, you're going to get a bunch of errors on the port. Sometimes the port will just shut down. Other times it will just operate very slowly because it has a duplex mismatch between both sides. Now, what I'm not saying to go through in your entire organization of 1,500 computers and hard code every single switch port to exactly the speed and duplex that it's meant to be. The reason I'm not saying that is the auto-detect mechanism has just a guesstimate. This is from my experience, about a 95% successful detection rate. Now, first off, this isn't a Cisco problem. It's not something that Cisco just implemented poorly. This happens across the board on any vendor switch just because the network cards are so diverse out there. 95% is pretty good, meaning that 95 out of your 100 computers will typically work okay with auto detection, but 5 of them will not, meaning you're going to get slow links and so on. So what my rule of thumb is maybe skip over the clients, the computers, and just hard code the key ports in your network, meaning ports to routers. Those are key ports. Ports to printers, ports to servers. Those are all considered key ports in my mind. And if we have a mismatch on those, it will affect far more than just one user who's not able to work efficiently. So those are the ones you want to go underneath. And in this case, I'll just demonstrate one of those interfaces. I'll go under interface fast Ethernet 0/1, which will eventually connect to this router. We haven't actually physically connected it yet. And I'll type in IP at, well, what am I doing? Duplex, followed by full. By default, it's auto. And in this case, speed 100. 100 megabits per second. And that is hard coding the speed in duplex. Now this interface is going to connect to our internet-facing router, so I'd like to attach a description. Again, descriptions I use sparingly. I don't do them on every port, just the key ports, so when I'm looking at my switch, I can get a quick feel of what's connected. Let me do this first, then I'll give you a quick view of that. I'm going to type in description, internet, router, connection. Usually when I type in description, I usually type them in all uppercase. And I do that for most things with a name, so I can see it very quickly in a running config, and I know that's something that I typed in. It's not a command. So that sets the description. And let me go back. I'll show you a bonus command, not really documented very well in Cisco at all, but it is show interface description. That's a great way where you can scroll through all the interfaces on your switch and see a quick view of what the descriptions are and see those key ports without having to do a full running configuration dump. Let me just give you a good idea of what this looks like. I have a switch that runs my home, and I'm going to tell it to that right here. I actually have no login on that required because it's protected from anyone outside of my home by my firewall. And I'll just do a show interface description on there, and you can see that I have all of these different interfaces. I have, my wife's IP phone. Yes, I have IP phones in my home. I confess, I am a true geek. We have the wireless, router, all of that. So this is a quick way that I can see. I even have a Cat5 port in our kitchen. But I have a quick view of all the interfaces and what they connect to. So if I'm looking for an interface, I can just do a quick show description and see exactly where those connect to. So that's a handy command. So that is assigning the speed, duplex, and descriptions of our interfaces. Finally, let's verify and back up our configuration. The first thing I'm going to do is use the Cisco Discovery Protocol to verify my network connections. I'm showing on my diagram that I have two routers plugged into this switch, and I did connect one of these up to the one of the fast Ethernet interfaces on the switch between the recordings. That was the one that we hard-coded the speed and duplex on. So we do have these connections, but the Cisco Discovery Protocol will help me map them out and see what ports are connected to what. So what I can do is jump into my switch and do a show CDP neighbors. Now I'm verifying that I have, it looks like the same router connected to two interfaces. But when you really look at it, you see, oh, those are two different platforms. It's just two different platforms with the same name, same host name typed in. So one of the first things as we get into our router configurations will be to clear the router configs. Now I can look right here, and this is key information because I see the local interface that is plugged into, which is the interface on the switch. So I can look and see one router 2 is connected to fast Ethernet 0/1. That's the 2611 router. I can tell you that's this guy right here. So this is, if I was diagramming it, I'd say FA 0/1 and label that port. The other one, I believe, was fast Ethernet 0/4. So I can label that port, FA 0/4. And I'll make this diagram pretty as we go through and add the pieces one by one. Now I'm also able to see the remote port ID, Ethernet 0/0 and fast Ethernet 0/0. Up here, I've got Ethernet 0/0, which is a 10 megabit per second port because it's just plain Ethernet. Fast Ethernet, FA 0/0, is my 100 megabit per second port connection. So now I'm able to label those key ports on my network diagram and even put descriptions on them eventually as we go through that configuration. Now remember, we can also type in show CDP neighbors detail and hit enter and see all the information about those switches. I can see what remote IP address it's configured with. I can see the platform that it's configured as. We saw that in the brief output. I can see the iOS version that's running on there. This one's running version 12.4 release 4XC. And I can, a lot of good information is displayed via CDP. Now we can also verify our configuration on the switch by using the show interfaces command. Just show interfaces will actually scroll through one by one, starting with VLAN 1, every single interface that you have, and all the stats about that interface. I scroll down even more. There's fast Ethernet 0/1. That's our internet router connection. I can see that that one has received 70 packets. Not too much going on there in the last 5 minutes. I can see the duplex. You can see it's set to full duplex 10 megabit per second because that is an Ethernet connection. Even though the media, the cable, can support 10/100, the router itself cannot. I can also do a show MAC address table, and we'll see if any of that has been filled in. The static MAC addresses belong to the switch itself. You can see the port is assigned to the CPU. And if I scroll down, there's my 2 MAC addresses of my routers that I've learned, Fast Ethernet 0/1 and 0/4. And I guarantee you when we go on the routers in the upcoming videos, we'll be able to verify that those are indeed the MAC addresses on there. Last but not least, I would like to back up our configuration. Now, I know I mentioned TFTP on there, and that is one way to back up the configuration. But until we get the full network set up, I'm not going to do a TFTP backup, because what I plan on doing is setting up a centralized TFTP server and having everything copy its backup config to that one server. For now, I'll show you the quick and dirty. It's actually my preferred way of backing up a configuration. First off, you want to save it. The official CCNA approved method is copy, running config, startup config. Enter. When it asks for a file name, you just hit enter because startup config is the default. Like I said, CCNA approved way. Real world, that's what you do. Write, which is actually short for write memory, is a quick and fast way to save your configuration from run to start or from RAM to NVRAM. Now, to back up your configuration, the quick and dirty way is to do a show run, scroll to the very bottom of that configuration, shoot all the way back up to the top, right there. You can choose to either start from here or from the first exclamation point and highlight everything. I'll do a Alt-C, which in TerraTerm is copy. Whoops. Don't right-click in TerraTerm. That will copy and paste everything. Meanwhile, while that action is happening, I'll open the ultra-sophisticated Notepad. Come over here, hide all that gibberish going on, and paste right there. That is a complete backup of the configuration. Ooh, looks like I've got some VLANs on there I still need to delete from the old config. I'll talk more about VLANs as we get deeper into the concepts. But that is a complete backup of all the configuration that I've put inside of this switch so far. There's my VLAN interface, my default gateway. And I say this is a complete backup in the sense that if I wanted to restore this config, I would just start from the first exclamation point, highlight down, to the very end, edit, copy. Now, I want you to imagine with me that this switch is a brand new switch, meaning it doesn't have config. I know it does, but imagine. I'll just come over here and go to Edit, Paste. What it's doing is pasting in all the configuration that I just backed up. If this were a brand new switch, meaning it had no configuration on it, right there would be the masterful way of reconfiguring it from scratch on the fly. Just like that. No TFTP server needed, no setting up IP addresses manually. That's, in my opinion, one of the best ways to do a backup and restore of your configuration. I promised a flyby, didn't I? Whew! I can breathe now. That was the configuration, the foundation configuration of the switch in the small office network. That was all the concepts that we talked about in the CCENT video series, with the exception of one, and that is port security. I plan on adding that later on, where we have locking it down to a specific MAC address, and only that MAC address can use that port. I don't want to do that yet because that will really throw us off when we start connecting devices. So what we did as we walked through is review a lot of the LAN concepts as we went through that configuration, and